All right, once we get beyond some of the fundamentals of classifying matter as either an element or a compound, we get to the fun part of chemistry, where we start to react those elements with compounds and get some chemical reactions going on. One of the fundamental laws that we need to understand when it comes to chemistry is the law of conservation of mass. One of the most important laws simply states that in a chemical reaction, mass is neither created nor destroyed. As we begin to then study the different chemical reactions and apply the law of conservation of mass, to make our lives a little bit easier, we begin to classify the reactions as one of several different subsets. The first of which is a synthesis reaction. And in a synthesis reaction, we have two or more substances that come together to form a new single substance. Probably one of the best ways to remember this is to think of a really skinny bird coming together with a giant worm. And after the skinny bird eats the giant worm, we get this big fat single fat bird, big bird. Here's an example of a synthesis reaction. We've got solid sulfur plus gaseous oxygen forming gaseous sulfur dioxide. Again, you've got two individual separate things coming together to form one. We also have a second example here. We've got magnesium coming together with nitrogen to form magnesium nitride. Again, two separate things coming together to form one. Our second type of reaction is going to be a decomposition reaction. In a decomposition, it's sort of the opposite of synthesis, where one substance breaks down into two or more. One way to sort of think of this, again, we start with one thing, in this case, an unhatched egg, and it decomposes or breaks down into the eggshell and the little baby turtle. Decomposition. An example of a decomposition is mercury 2 oxide decomposing into elemental mercury and oxygen gas. Our third classification is going to be a single replacement reaction. In a single replacement reaction, you have one element replacing another that's in a compound. A great way to sort of visualize single replacement reactions are to think about a dance floor. Again, imagine some single hottie on the dance floor comes into a couple that's dancing on the floor. The good-looking guy comes in, kicks the second guy out, and with some serious dance moves on the dance floor sort of replaces her previous dance partner. An example of a single replacement reaction would be the addition of solid aluminum to hot water to form aluminum oxide and hydrogen gas. Again, note how the one element kicks a second element to the curb. Your fourth reaction is going to be a double replacement reaction, and a double replacement reaction is one that results when the ions of two compounds exchange places in an aqueous solution to form two new compounds. One way to think of a double replacement reaction is to think of two gentlemen wearing two different hats. In a double replacement reaction, essentially, they would switch hats. To give you a chemical example of a double replacement reaction, we have the addition of aqueous silver nitrate to aqueous potassium iodide, and we form that precipitate silver iodide and potassium nitrate. Again, notice how they essentially switch partners here. Second example of a double replacement reaction would be the addition of hydrochloric acid to sodium hydroxide, forming water and sodium chloride. Again, the big thing to pick up on here is the switching of partners, if you will, switching of those ions to form two new compounds. And the fifth reaction that you have to be able to classify, arguably the most fun reaction in chemistry, are combustion reactions. In a combustion reaction, we get a substance to combine with oxygen, in which we release a large amount of energy in the form of light and heat. And when we have combustion reactions that involve hydrocarbons, that is, those compounds that are composed of just carbon and hydrogen, when they react in complete combustion, they will form water and carbon dioxide. Two examples here of combustion reactions, again noting that our products are water and carbon dioxide, again in complete combustion. Those are our only two products that will be produced.